Hello and welcome again to part 2 of our series of videos for section 7 in DMA 10. Now we're going to continue our discussion on algebraic expressions. Recall that last time we talked about some basic definitions of algebra as well as the various keywords that we use when writing algebraic expressions and equations. In this video we're going to talk about look at some practice problems and then some application and word problems as well. Let's get started with our practice problems. We're going to translate each of these 4 phrases into an algebraic expression. So let's start with the first one. The tax T added to C. Now remember, 2 was one of those words that we had to look out for because that meant our order was going to switch. So we're going to start with C. C is going to be first, and then we're going to add to that T. Okay. P, uppercase P, increased by twice lowercase p. Now, capitalization is really important when we're doing this. WebAssign will kick your answers back if you don't capitalize properly. So make sure that you're always pay attention to whether or not a letter is capitalized or not. So we're going to start here with the letter P, uppercase, increase by, that means we're going to add to it twice P. Remember, twice meant times 2, so we'd write that as 2 times P, like that. The third example, the square of K minus 2005. Okay, remember, square means to the second power with exponents. So the square of K is going to be K to the second power. We'd write that with K with a superscript of 2 minus 2005. Now for our last example, 1 less than twice the attendance A. Remember, less than is one of those phrases which means our order is going to switch, so we're going to start with the second half of this sentence here. Twice the attendance A, twice means times 2, so we're going to have twice A, and then less than means subtract 1. Let's continue with some more translation practice. First example on this slide, 3 times the total of 35, H, and 300. So keep in mind, 3 is going to be times the entire total. So you have to find the total first. Total means that we're going to add all these things together. So let's start with that. That's going to be 35 plus H plus 300. And how are we going to show times that whole total? Well, I think the best way to do that would be to put that whole total in parentheses, and then we can multiply it by 3 like this. Okay. Second example, decrease x by negative 17. Okay, so we're going to start with x, then we're going to decrease it by something, okay, and it decreased by negative 17, okay? So make sure you get both those negatives in there. And when I write problems like this with double signs, I'm usually going to put parentheses around that second number so I can easily notice that there's a negative here and a negative here, and I'm not confused that they both run together. So we get one negative here for decreased and another from the negative sign. Third example, the quotient of y and 6 cubed. Remember that quotient means divided, so y divided by 6 cubed. Okay, so this is going to be y divided by 6 cubed. We're cubing 6 here. But now let's look at the last example, the quotient of y and 6 cubed. There's a comma here, right? That comma is very important. Without the comma in the last example, that meant that we're just cubing the number 6. But when we stick this comma in here in this sentence, that means we're going to cube this whole quotient. We're taking the quotient and then we're cubing that. So when we write that, we're going to write y divided by 6. Okay, we're going to take that whole thing and cube it. So those commas make a big difference. Make sure you look out for those when you're working on your homework. Now let's get started with some application problems. Here we have a beam represented by this green bar here, and a pipe represented by this blue cylinder here. The first part of this problem says let B represent the length of the beam. So this length of this whole beam is going to be represented by B. Okay. Write an algebraic expression that represents the length of the pipe. Okay, so to do that, we have the whole length of the beam, and then the pipe is shorter than it. It's 15 feet shorter than this. So to write that as an algebraic expression, we're going to have to kind of chop off the beam, right? How much of it are we chopping off? Well, that 15 feet that's left over. To write that algebraically, we would say b minus 15 feet. Okay. The second part of this problem, let P represent the length of the pipe. So we're going to call the pipe P. Write an algebraic expression that represents the length of the beam. Well, to get from the length of the pipe to the extra length of the beam, we're going to have to add that extra 15 feet. So algebraically, we're going to write this as P plus 15 feet to get the length of the beam. Now let's look at the second application. Tom Petty was born 6 years before Tom Hanks. Tom Cruise was born 6 years after Tom Hanks. Write algebraic expressions to represent the ages of each of these celebrities. Okay, so we've got three celebrities here. We've got Tom Petty. We've got Tom Hanks. And then we've got Tom Cruise. Okay. And we need to choose a variable to represent an unknown age and then kind of relate them back to each other. When I do problems like this, I look for who's the common denominator in these sentences here. I see Tom Hanks pop up twice. Hanks is related to Petty, okay? And in the second sentence, Hanks is related to Cruise. So since he's related to both of the other people involved, he's always going to be my starting variable. We don't know how old Tom Hanks is right now. We don't have enough information to tell that. So that's going to be our unknown variable. And I'm going to choose Tom Hanks to be X. I could have chose A for age. I could have chose any letter really, but I just chose X for simplicity. Now I have to relate the other actors back to, or the other celebrities back to Tom Hanks. So Tom Petty was born 6 years before Tom Hanks. Okay, this is important. He was born before, so his age is going to be older. We might think, okay, before we need to subtract some years off, but no, he was born before Tom Hanks, so he's going to be older than Tom Hanks. So we write Tom Petty's age as Tom Hanks' age, X, plus 6, because he's going to be 6 years older. Now, Tom Cruise was born 6 years after Tom Hanks, so he's going to be younger. That means we have to subtract. So we start with Tom Hanks' age, and then we're going to subtract 6 years from that to get Tom Cruise's age. So to review for section 7, in our first video we talked about some definitions for algebra and different keywords for different operations to look for when working with algebraic expressions and equations. And then in this video we did some practice problems and application and word problems. Good luck on your work in section 7 and stay tuned for videos on section 8 where we start to evaluate algebraic expressions and equations.